So good morning, all. Here we are again, another video. I don't know if I posted the other one, but this is the part that I need to make for my Rockwell 21-100. And again, this sits up in the spindle drive pulley. And these are the two bearing journals, which are completely trashed. Um, this is pressed into the pulley housing. There's a key, there's some threading, and there's the top shiv, and this part is splined. And the splinal actually goes about an inch and a half. I think it's right around into here, about here somewhere. And then I believe it's turned off. I actually thought it originally that was from it slopping around, and based on everything else, I knew it was. But I think the whole piece is splined, and then they bore it out to the depth that they need because it's just a drive for the spindle. But anyway, so I'm going to try to make this from scratch, and I've hogged out a couple pieces, so this is my first attempt. And I was playing with the new lathe that I got at work here, and this is just some mild steel, and the dials, the handrails, however they indicate differently than what I'm used to. So I ended up taking too much off of that. So then there was attempt number two, and guess what? I did the exact same thing. I really overshot here, or undershot, depending on your perspective. And here I missed by, I'm not too sure, except it was close. But, yeah. So, try number three. Now, here's what I'm going to use. I believe it's the same material as this. I don't know if D2 means anything. It's shiny, and it turns extremely well. And that's got a great finish on it. So, that's what I'm going to use. And this time around, I'm going to be extra careful. And hopefully I don't screw it up. The intent today is to turn this whole length down to this size, which is the largest, and then turn the shiv. And bore it out to the ID between the splines. I'm not too sure I'm going to do those splines. I haven't figured that out yet. But anyways, so that's the intent. So I'm going to make that hole. I'm going to turn this down and hopefully make the shiv. And then I'm going to take it home and I'm going to clean it all up and I'm going to thread it on my little South Bend at home. I haven't figured out the threading on this big machine yet, and it's pretty clunky and inaccurate as far as I can tell. It's got a lot of wear on it, so I'm going to do this on the South Bend. So that's where I'm going to do the finish work. So there we are. Hopefully the third time is a charm, and I'm not going to bother the progress pics because I need two hands and I do this on my phone. But anyways, there you go. Progress reports. Okay, so take two. I reached the memory limit on my phone, so I had to do this over again, delete a bunch of stuff so I can get this video in. So anyways, here is my soon-to-be replacement drive pulley hub. So now on this, here's the original shiv, spline. Spline doesn't go all the way. There's spline, keyway, bearing journal. This is a press fit into the pulley, into the step pulley, and then there's the threaded section to develop the preload on these bearings. The bearing journal is it's a slip fit, and I'm going to shim it. The original bearings were ground to create preload on the inner races. I'm going to shim the outer races to create the preload on the inner via the nut. So regardless, all right, to the point before I run out of memory again. So here's the replacement. Now, I don't know if you can see the witness marks or not. There's one there, one here, one here. Everything's been cut to the correct diameter. So I've got my press fit here. I've got my slip fit here for the bearings, and then I've got the ID or the OD I need for the thread, which I think is a 13 or 16. I can't remember off the top. I've already measured it. I still have to cut the keyway. Still have to thread it. Still have to do cut the shiv out. And I need to bore it to size and do the spline. So here's where we're at. I had some extra meat here, maybe about 3/4 of an inch, and then I got about maybe another, not quite an inch there. And I like the extra for the work holding, but unfortunately, I need to bore this out to size, and it's a weird size. It's not a drill size. So I drilled this as close as I could get, and now I got to bore it out. Now, unfortunately, I've got some limited tooling. So I don't have a nice fancy boring bar that I can just pop in here with an insert and go to town. But what I do have is this little rig. So now this is the one I use at home with my little South Bend lathe. It's a Loris knockoff, little import. works for me. And fortunately for me, the quick change here at the work lathe, this slips right in there, and it gives me the right height. So I've extended it as much as I could, and I just didn't feel right about it. So I decided to take the meat off. So I'm taking that off. I'm going to flip this around. I'm going to take that meat off, and I'm going to hold it from right here. This is the bearing journal, because that's what matters. Everything else needs, that's my datum. Everything else needs to be square to that. So I'm going to flip it around. I'm going to hold it from here. I'm going to take that off. Not the face of this is going to really matter, and not that the shiv matters all that much, but my boring matters. So I'm going to hold it from here, square up to here. I'm going to bore to this ID, and then I'm gonna do the bore to that ID all the way across to the inner spline, and that only goes about 1.5 inches in there. I haven't taken a measurement of it, and then I'm going to bore to depth to or whatever it is. So it's going to be one shot to this, and then somewhere down to around here somewhere, I'm going to open it up the rest of the way. And then while I've got it in here all chucked up, I might cut that. I'm not too sure yet, because I still have to do the spline, and I'm gonna have to do some fancy chucking to hold on to here when I do the spline cut. So I may leave that to the very last step, just so I can hold it there. But anyways, that's where we're at. I'm about to bore it out. Unfortunately, I can't set this up and show you tedious hours of me boring this out. I'm not as fast as the other guys that like to post their machining videos. So it's just a quick little update. That's where I'm at. And when I get back, I'll have this bored out, and I'll probably have the step bored out as well. Now I've taken the we're down to size now. So I've taken the extra. Sorry, I don't know if you word frame or not. But, okay, so I've taken the extra meat off that end, and again I've got everything turned down to the desired or the needed dimensions. So now my next step is I'm going to bore this out. Now I haven't cleaned up the ID because who cares? I'm still going to mill it out. So that is the top side. And there's the bottom side. So now the ID is different because of the spline, and this ID is larger because there's I believe it's because of the drawbar, the nut and washer on top of the drawbar, and that's the allowance. That's the allowance for the drawbar nut and washer. Get down inside. So now the reason I'm making this, I was just taking a quick look, and I was wondering if I could tighten up the tolerances a little bit. So now here's the original. Here's the spindle. I was trying to call it to see how it fit, but anyway. So here it is. Might have seen a video on this before. I can't remember. I make so many. So there's twins. There's a set of bearings here. They get preloaded together. There's a single bearing here. Now this guy is up in here somewhere. Okay, so now that's the pulley. So now it gets bigger as it comes down. So there's another set of bearings here. Now this set of bearings really doesn't have anything to do with the spindle. It's just to keep everything square. But they preloaded this as well. I'm not too sure why, because there's a crazy amount of slop there. But anyway, so my intention was to I thought I'd see if I could tighten this up a little bit. So now what ended up happening? Pardon me, I'm doing this with one hand, holding my phone in the other. But so get this. There we go. All right. So now, as you pull down on the quill, or you lower the quill, this slides. So now there's a little bit of axial play right there, which really, in the grand scheme of things, whatever. I mean, as soon as you start up, it's going to dink, and it's going to load up on the spline, and that's that. Now, the rattle that I heard when I ran it is actually a lateral. I'm not sure if that's the right term or not, but it's sloppy this way. So there's play in this, and combined with the bad bearings, this was actually slapping back and forth. Let's see if I can use my dominant hand here. So it was doing that. Now that's axial. Don't confuse that, which really isn't going to happen, because as soon as you're running and it's spinning one way, you're fine. This is, you see it slapping back and forth there? That's brutal. So I'm wondering if there's an opportunity there maybe when I cut my spline, or when I bore out my hole, I'll make this just a little bit tighter. So, because the OD of the spline, right, sits inside here. So now if I make that a little bit tighter, I take a little bit more time making this, this spline and this blank, I think I can take some of that rattle out of there. Now, I don't know if it's going to be in there when all the bearings are set up and preloaded and what have you, but I think there's an opportunity. So I'm going to try it. And, well, the worst case scenario is it doesn't work, right? And I go back to it and I open it back up again. You can always take away, you can't add. So anyways, there's where we're at now, and those are my plans. I've got this out now, and I've let it cool down. I was hogging some pretty good material off, and I got it all nice faced up. So I might get into the shift tonight. Again, I might not, because I want that for when I'm cutting my spline, but which is this part here. But all in all, getting there. Tonight I hope to I'll bore that out. Grind my tool for creating my spline, and I don't know if I'll get adventurous enough to cut that keyway or not. I don't know what's better, what to do. Do the keyway and then thread, or thread and then do the keyway. I mean, either way, it's going to get pretty gnarly in here. I'm going to have to do some cleaning up. I'm not too sure yet. Anyway, I'm doing that in South Bend anyways. But the mill I'm going to use is here at work. Because obviously my mill is getting set up to do my my keyway. This 3/16 keyway in my blank that I'm making up here. And this is a new machine to me. I haven't touched this before. It's this mill's seen some pretty good years. Siki, whatever that means. But so anyway, I don't have any of my machining tools here. Well, I've just got a handful of end mills. So I'm struggling to get dialed up here, and I think I've got it sorted out pretty good. So what I ended up doing, I've got a little back indicator on a little Noga quill mount arm. So I checked the back jaw, the fixed jaw on the vise, and it's within a thou. So fantastic work there. I'm not going to touch that. So now what I need to do is I need to come out from here, my datum, to the center of my shaft for my keyway. So I measured, what I'm going to do is I'm going to clamp it on the biggest diameter, which is down here, which is the press fit into the pulley. So the plan is to put her into there and clamp down good and solid. So now, what I did was I measured the largest diameter, which ends up being 1.386. Obviously, I need half of that, so it gives me 0.693. Now I needed to indicate off the back of my jaw. I needed to find my my datum. So I had a 3/8 end mill that was long enough to give me some shaft to go butt up against here. So what I ended up doing is I chucked that up, and I dialed in the 3/8 end mill, and I used a piece of 1/1000 shim. And as soon as I couldn't move it anymore, good enough. So now I've zero. Well, I didn't zero the quill, but now I know where I am. So I'm a 3/8 off. Half of 3/8 is 0.1875. So now I know where the center of my quill is. From there, I need to come up the rest of the distance, which ended up being half of my 3/8 minus this was just over 500,000. What I decided to do is I use a dial. So now I've got this dial. Sorry for the wicked shadow. This dial goes up to half a thou or 500,000. So what I did was I squared it up with the way, and I pushed it in, so I've got enough rotation to get me past the 500,000 mark. I zeroed it, and now I'm gonna put in my y-axis, and I'm gonna count 5 full revolutions, and then an extra 5 thou, and that will put my quill center over top of my shaft. Next thing to do is put the appropriate ML in and then go to town. So hopefully this works out. I've got a fair chunk of work into there, and I'll double check and I'll make sure I'm good. But there we go. It was interesting to come up with a workable setup here, but I think I've got it. Hopefully everything works out okay. So I've got my end mill in there. I got my 3/16 end mill. I know I'm visually I look eyeball centric. I look centered, and so it just dawned on me that I didn't know whether or not I was good this way or this way. So I grabbed the work dial and I threw it in there, and it's a little haphazard, but it's holding well. These ER called systems, I'm not a fan of it, and I just didn't want to bother chucking up the Noga again. So I've got the mill in there. I know it's right. Everything's okay so far. So I thought I'd throw it in there. Now I was just checking this. So now there's a bunch of steps here. So this is now the threaded portion. Focus in here or not? It refuses to focus in. It must be. Bear with me for a second. Sorry. Huh. I don't know why it's not focusing. And there we go. So anyways, so this is the threaded portion. And as I tram across it, I'm pretty good. Oh, there's the step. So now that's the bearing journal. Nice and steady. And then jump again. And that's my press fit. Bang on. Perfect. So I know I'm golden there. So the next step to do is I'm going to zero off of here because that's the best part. I guess the threaded part's not that bad, but I'm gonna zero off there because that's the best spot I got. And I might not even bother. I know the 3/16 key, and I know it's halfway, so maybe I'll go down the 1875. Finished the keyway, not with a little bit of drama. So I got it all milled in, and it's very good. I touched off down in there. I got a bit of a wetness mark. The end of the world, but it's annoying. Don't like doing that kind of stuff. But and I got really lucky. Ideally, when you do a keyway, you don't use the end mill that's your finished size. So I need a 3/16 keyway. Well, I use the 3/16 end mill. Now, I mean, if you've got a perfectly running machine and your quill's 100% and everything's 100%, I guess you get away with that. But with an old clunky machine that I was using, I'm actually surprised. I've got a nice sized keyway here, and it holds onto a key quite well. And that plays into my next problem. So now, I don't know what I did. I don't know how I did it, but I'm a little shallow on my keyway. I'm 40 thou shallow on this keyway. Now, here's my problem. What's the likelihood of me being able to get this back in the mill completely squared up so I could mill another 40 thou in depth and not screw up my fit side to side? I say it's pretty damn unlikely. So I think I'm not going to bother. It's a 3/16 key, and I mean, if I have to, take the height down on the key just a little bit to get it fit right, fine, so be it. I don't know how much load there's going to be, but I'm more concerned about a loose fit side to side than I am with a little extra vertical or a little extra depth. The depth just gives you a little bit more torque. I don't. It doesn't give you torque, but I mean it handles torque better. A good side to side stops things from chattering. So a good fit that way is, in my mind, more beneficial in this particular application. I mean, if there's a high load, high torque, then I'd worry a little bit more about the key, sitting in your keyway, and twisting, that extra depth would give you more engagement. But as it stands, I don't want to risk ruining my fit for sake of some depth. I'll have to rework my steps and see where I made the mistakes so I don't do it again. But I'm not going to trash this part for sake of 40 thou worth of depth. Anyway, there we go. Keyway's done. Needs to be cleaned up just a little bit. And what have I got left? Spline and threading. Oh, and the shift. So, yeah, that's the last step. So next on the list, I think I'm going to make up. There's the step for that's the spline section. That's smaller than that. So next step is tooling. The tool I need to make the spline. So I've got the spindles together as far as I could. There's a spring washer goes in here before the bearing, so I couldn't do that, but she spins nice. I had it going up to about 1600 RPM in the lathe. There's nothing gnarly in the bearings, so that's exciting. Things are coming together. I'm pumped. I think I might bang off a couple more shims for the bearing set that goes on this particular piece, even though I'm not going to need it. I've got everything out, so I might as well finish that off. And there you go. Progress. Thanks for watching, guys. I appreciate it. It's been an adventure. Oh, another project. I think I might wait for the mill to be operational before I tackle this one. That's some other day. So anyways, thanks for watching.